Okay, today is lesson 5, Venn diagrams and expected value review. So basically, you have your big test. It's not big, but you have a quiz. Same size as last week. About a week ago, you had a test, and it was a bubble test, you know, and there's going to be another one of those on Monday. They're deadly because they're short, and that means you get 2 wrong, all of a sudden you got to beat, literally. So you want to know your stuff well. All right. So let's practice this. And the hardest parts, I think, are 2 things. Number 1 is givens. When they change the given, they're changing the denominator, or what it's out of. And that's really, really important. Like on this first one, what's the probability of randomly chosen rock climber? Stop right there. As soon as they said randomly chosen rock climber, they didn't say we picked from everyone and we got a rock climber. They are saying, by saying it that way, that we randomly chose from only the rock climbers and we got a snowboarder. And that confuses people sometimes because they're like, but you said he was a rock climber. Well, apparently they're also a snowboarder. So as soon as they said randomly chosen rock climber, I hope you said, well, I can only use these 2 numbers and I can't use that and I can't use that. That's the really important part on Venns, is like just be liberal with your pencil and like crossing things off to narrow it down, because the biggest mistake is to use the wrong numbers, and if you cross off 2 of them, heck, you only got 2 left. It's, you know, it's not too hard. One of them's got to be, you know, important of these 2. All right, and maybe both. We'll see. And then it says the probability, and this is a modifier, blah, 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 blah. The probability that they, this is like the noun, is a snowboarder. Okay, so snowboarder. That's snowboarder right there, 0.47. I know that's important, but is it just 0.47? No. It's 0.47 out of, now if we didn't have this given, we could just say divided by 1, but we have the given thing, and the given narrowed it down. So now what's possible? Everything? No. Those 2. So those 2 together is 0.59, and there we go, 0.47 over 0.59, which, if you divide them, comes out to 0.797. Who can verify they got 0.797 before I even said it? Okay, good. If you haven't already, you might want to get your calculator out, so that'll be helpful. What's the probability a randomly chosen person, ooh, they're picking only from people. Okay, well, actually, that doesn't narrow it down at all. Is a rock climber or, okay, so the key word here is or. Or is a big answer. Very good. And by the way, what could they have used for a little symbol for or? Is it the U or the upside down like horseshoe looking thing? It's the U. Or is this. And it's kind of like, oh, I shouldn't put it by the and. I'll put it right up here. It's kind of like, or is like, oh, you could be on the left hand or the right hand. You know, get your hands up in here. Or, I don't know, this one or this one. Anyway, but or actually means you're going to add up a whole bunch of things. So be careful using the right one for and or. And is that, and I like to think of it as A and D. You know what I mean? Like it's the N in the and. And that's what and is like. And that's also called an intersection. I don't think we would test you on that, but we would expect you to know that symbol and that symbol. And that's like, oh, the left hand or the right hand. And it's like a big group. It's a union. It's like everybody can come in. It's like you got your hands over your head saying, come on in, everybody can come in. Yep, you and you and you. Okay. So this and this and this. Raise your hand if you had those 3. Okay, good. And what about and? Just the middle one. And if you, I like this technique. Ask them, do you rock climb and snowboard? And they would say, no. Do you rock climb and snowboard? And they would say, yes. So there are people. They're the ones. 0.47. And lastly, this one, oh, shoot, I was going to pull down this one to see the 0.47. Okay, now we've got an answer there, but let's see what the question was. Given a randomly selected person is not a rock climber. Ooh, given they're not a rock climber. Now circle what's possible on your iPad. Circle the part that's possible if they're not a rock climber. Did you circle these 2? All right, and those are the ones that are possible. They go on the bottom. Added. Adds up to 41. On the top is the probability he or she is not a snowboarder. Here's a common mistake. These guys are not snowboarders, so I'll put that in there. I can't choose from those. Those aren't possible. That's another reason that if you circle some that are the ones you want, scribble out the other ones, and you won't by accident grab them and put them in your answer. Okay, which are not snowboarders then? Just those. 06. So it's 06 out of 41, and that's what comes out to 0.146. Any questions on that? Sir? Given the randomly... To start with, I said, given not a rock climber. That's why we crossed off these. And those are the only ones possible. All right. Then it's not a snowboarder. That's those.
And that's neither snowboarder or rock.
Right. Very good. Okay, moving on. This is one of the hardest kinds. And this is extra hard because we did not tell you the center one. We didn't tell you the center one as straight up like, oh, you can just write a 6 in the middle, because that's the people that have an iPod, a cat, and a phone. Okay, they didn't ever tell us that, so you'll have to deduce it. So let's start with, where would you put the total number of people for the survey? You actually, it's not necessarily supposed to go anywhere, but I personally have always put it in the upper left-hand corner. Just kind of like we usually put the neithers in the lower right-hand corner, you know, down there. I put the total for the whole group up here. You do not have to, but it's smart to put it somewhere. Then, as soon as they said 26 have an iPod, do you get how a lot of people go like this? 26 iPod. And that's wrong. Because the whole thing together adds up to 26. So I'm going to put it right underneath iPod. And then I'm hoping later they'll tell me more info, which they will, so that I can figure out that this and this and this and this and this all add up to 26. All right. I'm going to stop talking and let you deduce this. Figure out what every single spot is. You can do this. It's not easy, but you should practice it, because it'll be the toughest one on the test. When you get one like this wrong, and all of a sudden, like you probably just went from, you already had one wrong before, and you probably just went to a B. Okay, so let's practice it. I will pause while you work this one out. So we're back. Now, I asked the class, and only about 7 people were able to pull this thing off like 100% right. So let's talk about where common mistakes are made. The 26 I put right here underneath iPod, and we knew later these are going to all add up to 26. So how can you be wrong if yours all add up to 26? Because there's more than one way you can make them add up to 26, right? All right, so let's think this through a little further. 4 people don't have an iPod, cat, or phone. If they don't have either, then you put them down here. How many of you have the 4 correct? Almost everybody's got that. Okay, good. 12 have a phone but not a cat, and this is where we start getting in trouble. 12 have a phone but not a cat. Or, okay, this is important. 12 have a phone but not a cat or iPod. Okay, that's important. They have phone, that's in here, but not cat, not iPad. See what I just did there? If you scribble it all out, then you can figure out where to put it. Okay? So that 12 goes in there. How many had the 12 in the right spot? Okay, that's almost everybody. Good. Next one. 4 people have an iPod and a cat, but not a phone. Oh, this is getting complicated. 4 people have iPod and cat, not phone. Here's iPod and cat. And then when they say not phone, can't go there. That's why that's a 4. How many have a 4 in that spot? Almost everybody. Okay, good. Next one. 6 people have a cat and a phone, but not an iPod. That's this same exact way to say it. Cat and phone, not iPod. So that's why it leaves that. You see how I'm crossing things off so that I only have one place I could put it? All right. Then where did you guys all make your mistakes?
Right here.
Oh, this next part. Okay. 15 people have a phone and a cat. So I'm guessing at this moment you thought you should put 15 in this middle spot then. Ah. Why can't I put 15 there? Because here's where phone and cat is. That's 15. If that's 15, then how much goes in the middle? 9. Do you get how 9 and 6 makes 15?
Yeah, 50 people have a phone and cat.
Okay, hold on. Okay, 15 people have a phone and a cat. Would you argue that these people have a phone and a cat? Okay, and you were thinking all 15 should go there. But don't these people also have a phone and a cat?
Well, I thought and was only one, small. I thought and is small and
It-
four is big.
Yes, but and is an overlap of two things. These are the two things that are getting overlapped right here. This is the and every single one of them has been 2 spots. Whenever we say and on these, they've always been 2 spots. It's just what bothered you is there was already a number there, and you thought, oh, empty spot, I'll just drop it in there. That's the classic mistake, is almost always because you put a number in directly. And if you just put a 15 in, you better be really sure that that's right, because together these make 15. That's why this is a 9, because there was already a number there. All right, well, I'll say it one more time. Do these people have a phone and a cat? Yeah. Do these people have a phone and a cat? Then together they add to 15. All right. And the last thing is 14 people have an iPod and a phone. So 14 people, where's iPod and phone? It's going to be 2 spots. Here's iPod and phone. Those 2 spots together make 14. And I bet a lot of people had a 14 like right here. And that's the wrong answer because together they make 14. So the mistakes are made when you take a number like this 15 or this 14 and you put them directly in on their own spot because they're together with something else. On a triple Venn, there's almost never a number that when we give you a number, we almost never give you a number you can just drop right in. It's almost always something you have to calculate before you drop it in. That's why I thought it was so surprising when we actually did drop in this 12 here, because the 12 usually is, oh wait, I can't put the 12 in, I got to put in a couple of numbers that add to 12. But this was the only one out of all these things that you could actually just drop in directly. No, wait, I guess we did also give you this 4. So those 2 dropped in directly. All the rest of them we had to like calculate. And how do you get the very last spots? Well, they're going to add up to 51. So if you have everything else done, then you just add them all up and see how much you're short of 51. And then you take the rest and you put it in. For me, my last spot I did was this, and I got a 3 so that I could get it up to a total of 51.
Kind of hard to check the work.
It is. How about this? Do you get that you could have checked a couple things? You could have checked that for sure your numbers here added up to what? 26. And I bet you if you did it wrong, that it wouldn't have, and you'd have known something was wrong. Okay. Another thing you could have checked is that the total added up to 51. But since you kind of just made the last number work for that, you know, you probably, that doesn't really help that much because you just faked the last number based on what any mistake you made. So that doesn't help that much. All right. So my last piece of advice is if you're ever given a number and you're tempted to just drop it in directly, you might be doing it wrong because that's what most people did with these 2 numbers. They stuck them in directly where they should have added 2 numbers to get 15 or 14. All right, that's the toughest kind. I warned you it'd be tough, and it would bore it out with only 7 people getting it right. So watch out for it on the test also. When we have you make a Venn, that's going to be when you take your time and make sure you're not dropping numbers directly in unless there's like a reason you should. All right, this one is a probability Venn. That's different because there's no whole numbers here. These are all decimals. That means they're already probabilities. The thing you really got to watch out for is givens. Here it starts with the given. So the first couple really aren't too hard. Cat or phone? What does or mean? A big answer or small answer? Big. So cat or phone is going to be all that. That makes sense? Okay, so who's got a smarter way than adding those all up? Yeah, take 100% or 1 and subtract that and that. Oh, wait, and that. There we go. Subtract those two off. That's faster, isn't it? Okay. But if you really would rather add, it's fine. Maybe you're really smart to do it both ways, and if they come out the same, then you know you double-checked yourself. You're sure you're right. Sir?
Why did we add 0.078 to the cat or phone?
All right, so here's the question.
Well, I just asked them. I asked, do you have a cat or phone?
Exactly, that's what you do. You should ask them, do you have a cat or a phone? And these people, unless they're a really annoying person, say, no, I have a cat and a phone. They will all say, yeah, I have a cat or a phone. Yeah, I got one of those. So everybody in there, if you ask them, yeah, I've got a cat, or I've got a cat, yeah, I got a cat, yeah, I got a phone, yeah, I got a phone. Okay. So I like that technique of asking the numbers, asking the data. Do you have a cat or a phone? If you talk to your test, I won't think badly of you on this test. All right. So if you're talking to your cat at home alone, and now that's no, actually, that's okay. Your cat likes to listen to you. They like to. They're kind of verbal. Yeah. If you're talking to yourself and you think the cat's talking to you, that might be a problem. Oh, geez. Okay. Okay. Well, sure, they meow at you, but if you like understand them and you're like, oh yeah, I'm having a bad day too. I mean, then I think. Okay. Cool. So are you saying that we could okay, I bet you dogs can communicate certain things with barks too. That's not the question. Is can they communicate? Because like dogs. Yeah, he's like shaking though. But what with dogs? I know from having I was raised with dogs, and so I've had them for a long time myself. And you know, when I remember I'm really annoyed with you groan, like that. My dog was just like, just stop doing that. You know, I was like trying to push him off his pillow, and he'd be like, knock it off or whatever. And then there's the I'm kind of scared, you know, kind of like the, you know. So yeah, they definitely communicate with you. I'm not saying they can't communicate with you, but if you think they're carrying on a conversation with you, and you're like making up words for them, I don't know. Actually, we heard from that senior who was saying that he talks to his, what was it, his cat? His dog? And he has good conversations with his dog. I think it's kind of cool in a way if you realize that you are making up the words for them. Then as long as you don't actually think they're really saying the words. Okay. So anyway. How many of you are done? We really ought to try all of these. How many of you are done with all of them? All right. That's a fairly smallish subset. I'm going to start the first couple. Those that aren't done, try to whip out the last couple quick. So, or, big answer, add them all up, 765. That should have been easy. And, small answer, but not necessarily just one thing. In fact, when it's a triple Venn, an and usually means two things. Okay, iPod and cat is where they overlap here, and both of them are iPad and cat. The common wrong answer is 0.078. You should have added them together, and you'd have had 254, and that is correct. Next one. Given they have a phone, I said that would come, that the givens would be the hard parts. Given that you have a phone, I like to do it this way. Given only these then. So I also cross off everything else. Why do I cross them off? Because you will be tempted to use one of those numbers. When they say also have an iPod, you will find people that have an iPod and think they're in your group. You think they were in your group, you would think they were in your group, but they're not. Because the given says you can only use those 4 numbers that I circled. So if I can only use 4 numbers, which of them actually use the iPod? Just those, true or false? False. Those and those. There we go. Okay, those and that and that together. And is it all divided by 1? No. It's divided by all of them added together. So I don't know what that number is. What did they actually all add up to? 627. Thank you. And then the two that are on the top here is 098 plus 176. Grand total, 437. Raise your hand if you had that one right. Okay, good. And this is the last and toughest. Given they do not have a cat, I'm going to erase everything here so you can figure out which ones are the ones you can work with. Then, once you only have that subset of them, you add them all up and they go on the bottom. I would always do that first, because otherwise people forget to divide by that. So once you find the ones that are possible, the givens, add them all up, put them on the bottom. Not having a cat. These people have a cat. Can't use them. Can't use them, can't use them, can't use them. Not having a cat is all of these people. All right? Then, those things get added up. They put them on the bottom. And we want to say, what is the probability that they only have a phone? Do you only have a phone? No. Do you only have a phone? No, I have a cat too. Do you only have a phone? Yes. Oh, so you're my person. So 0.235 out of all of those, so the ones that are circled are added up and put on the bottom, and you should have got 414. Anybody get 414? All right, that was a tough one too. It was the second toughest problem that we had. So, all right. So be careful with the givens. Givens make what's possible. What's possible goes on the bottom. All right. This is the last and one of the most important kinds. You are definitely going to see at least one, probably two or three of these protection plan deals. Partially because we personally, as teachers, know that this is something you see in the real world, that you can use math and figure out if it's a good deal or not. The only thing you never know on these protection plans, you know the price of it, you know how much you're going to get if it works, you know how much you're going to get if it breaks. What don't you know in the real world when you're walking up it, buying a plan? Probability of breakage. That's the thing you really don't know. Like, you can't tell just by looking at this thing whether it's going to break or not. Now, would you agree there are some things you can look at and they seem like going to be more sturdy than other things? All right. So if you get a brand new, like glass butterfly, well, that might be more likely to break, especially in my little brother's room, or because I got cats running around pushing things off counters or whatever. So, trying to talk to me, yes, exactly. So, I would recommend that you do this in the real world and you figure on you just have to go with your gut on something like this. What percent of the time is it going to break? And all you can do is, like I did, is ask you guys, ask your friends, like, have you ever had one break? You know what I mean? People usually don't have time to do all of that. They just kind of make a gut decision in the store. And usually it's like, well, I won't have to worry about it if I buy the plan. So what they're really buying is peace of mind. And it's actually okay to pay a little bit of money for peace of mind, because then you don't have to worry about it. Even if it's smarter to, in certain cases, not have insurance for your car. Just to clarify, you have to have car insurance to be legal, but you don't have to insure your car's damage. In other words, your car might only be worth $2,000. If it gets a dent in it, it probably isn't that, you could probably live with it if it's only a $2,000 car. Okay, so some of the older cars that are out there have full coverage on them, and you got to pay a lot more for that to cover the car itself. What you have to have by law is the coverage that covers the other guy that you hit. Like, if you hit somebody, you have to have insurance to fix them up, but you don't have to buy the insurance to fix your own car up. So anyway, a lot of people make that mistake about insurance, just deciding what's the risk. And anyway, this, I'd like you to make me a tree, works and breaks. And you're going to figure out a P, that's an easy part, and a A. Sometimes you have to think that through. And then P times A, will give you an answer. And then what do I do to those two answers? Add them all up. And at the very end, in my opinion, you wait till the very end, and then you subtract off the cost of the plan. I would not use this $19.99 until the very end, because the cool thing is you'll find out the fair price of this plan, like what it should have been priced at if Mother Teresa were running the store and only wanted what was best for you. She would have priced it at this, okay? But the big bad companies, of course, want to make a profit. Obviously, that's what companies do. They want to make a profit. But if you first figure it out without the $19.99, you'll get the fair price. All right. So do you get that since we know that 3 and 200 break, this is 3 and 200, and this is 197 out of 200. You with me so far? Okay, that's the probabilities. Now it's the amount. How much do you get when you walk into the store and say, hey, my picture frame works? 0. Like so, isn't that supposed to work? But if you walk into the store, having bought this warranty, and you say, hey, my picture frame broke, they're going to be like, oh, no, don't worry about it. We'll process your return here, and we'll get you a new one. And so therefore, even though technically all you're getting is a picture frame, it's worth 100. Now, I know some of you have looked at the keys and have noticed that they will do this slightly differently. They subtract the $19.99 off in 2 spots. They subtract $19.99 here, and they subtract $19.99 here. I used to do it that way, but then I realized that, number one, you have to do it twice instead of we're just going to do it once at the very end. And number two, you don't get to multiply by 0, because I like multiplying by 0. It's fast. It's 0. You know what I mean? So this way is slick in 2 ways. So I personally don't like to do the $19.99 until last. So that part's 0. This part is 3, comes out to 1.5, right? All right, because what I did there is I got 3 times 100 is 300 over 200, and I reduced it down to 3 over 2, which is like 1.5. Okay, that means the cool thing, again, you get out of this by waiting is you can see the fair price of the warranty. They should have just charged you $1.50, but again, we understand they want to make a profit, so they're going to mark it up to like $2 or $3, right? Actually, they marked it up to 20 bucks. This is why they want to sell warranties so bad in those stores. A lot of times they'll say, as you're checking out, they'll be like, sure you don't want to buy the warranty on that? If you buy the warranty, you won't have to worry about this or that. And they're trying to get you to give them a nice big profit. Because once I factor in the final minus $19.99, it comes out to you are at an expected value of a negative number, which always means don't do it. Unless the peace of mind is worth it to you. But you're paying a lot for the peace of mind here. $18 and, help me with this one, 49 cents. All right, I had a 0 missing there. Okay, good. That means that your expected value is negative. What's the store's expected value? Positive, exactly the same amount. If you're losing 18 bucks, they're gaining 18 bucks. That's why they want to sell those warranties. And frankly, the store also has a reason to sell warranties, which is that customers whose stuff breaks, if they have the warranty, they're still happy customers. If you just bought this picture frame and then like 31 days later, just past the return time, it breaks, you're not a happy customer. You're an angry customer. They don't like that. So if they can get you to buy the warranty, it's extra good because they'll have less angry customers. All right, so that was the expected value. We've done a few of these now. Do you see the reason why I switched to only subtracting $19.99 once at the end? All right, and you can choose either way. It does work. You'll still get $18.49 if you do it here and here. You got to subtract it twice though, and you get 2 different numbers here, and you never get to multiply by 0. So, but your choice. All right. This is probably the hardest question. I'm going to go really fast. I'm going to make a tree for this and say if he's as a 3-day week, I would have to make a tree that would go like this, a really massive tree. It would take us a really long time, and I don't want to do that today. Okay, but once I got the tree done, 2 days out of 3, I would look for which of these results here, 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 there's going to be 8 of them, which of them he was on time exactly twice. And if it was like, that wouldn't be one of them. Let's say it was here and let's say here. What do I do to him? Add them up. You got to find the ones where he's on time twice. Late, 1 day out of 3. Again, you'd find the route. Maybe this is where he was on time, late, late. Oh, wait, we wanted 1 day out of 3. On time, late, on time. That's one of them where he was on time, and then he was late, and then he was on time. He's late 1 out of the 3 days. You'd find all the ones that apply and add them all up. Then, expected value, it's a P times an A, and you add them all up. They take a while to make, but once you make a tree, you got all the probabilities. You just got to times by amounts, and then add them all up. The amounts in this case are not amounts of money, but amounts of days he was on time. Here is on time, on time, on time. And so this spot right here is worth 3 because we're looking at on times. And his expected number is the P of that, which you'd multiply all these out and you'd have it here, times the amount is 3. And I do that for everyone and add them all up. So expected values aren't always money. Sometimes it's soccer goals. And then you got to say, well, my probability I got because I made a tree, what's my amount in soccer goals? You just look at the branch and say, oh, you got 3 goals. On this one, he got 2 goals. On this one, he got 1 goal. And this one at the bottom, he got no goals. You'll do your P times A and add them up. All right, that's your summary. And your homework is that one right there, 12.3, 12.4, and we're going to do them all and check them all. You got a weekend, strongly recommend it. Got a test on Monday. You take the weekend off, you're just going to not do so hot on this test. Okay, that's the plan. That's all I have for the video for today.